Well, good afternoon, ninth graders. I got a text sometime yesterday which said you may not have finished the first video. I don't know if you're the only class it applies to or if it even applies to your class. So if you don't go through this video, totally fine. We will take a look at these things some other time. But I am going to go through as much as I can here today. And, of course, today is going to start out with a quiz. Now, if what I believe to be true is true, and that is that you did not finish the video yesterday, this quiz is not going to count against you. Okay? But, if you did finish the notes yesterday, it will count. So I'm just going to have to see when I get back and make a judgment call on those things. Of course, significant figures are considerably difficult. So what I'm going to have you do is pause this video, shut off the Mimeo because it does give you some hints as to what is significant even within this PowerPoint slide. And I'm going to allow you to take this quiz now. Alright, so presuming the quiz is over, we are again talking about significant figures. Now every year I've taught this. I've taught 9th grade now for 6 years. Every year significant figures has been a struggle. And it's because people just don't grasp the idea of zeros. That zeros between non-zeros are significant. Zeros after non-zeros are insignificant unless there's a decimal. And zeros before non-zeros are insignificant. Take, for example, the following number. And that is 15. Well, technically we could write this, right? And it'd still be 15. So this 0 is insignificant. It doesn't do anything besides hold the hundreds place. We talked about adding and subtracting significant figures. When you're adding, you want to go to the place of the least significant number. So in this example, you have the ones place, tenths place, hundredths place, thousandths place, and the ones place. This one is significant to the thousandths place, this to the ones place, so the answer has to be rounded to the ones place. And you see that answer is. Now technically the answer is 13.022. But we have to round to the ones place. With multiplication division, you have to have a number of significant figures of the least significant factor. What does that mean? This guy here has 3 significant figures. This has 1 significant figure. Since 1 is less than 3, your answer must have 1 significant figure. Now, if this had 2 significant figures or 3 significant figures, it would be 2 significant figures and then 3 respectively. And, of course, these things are kind of difficult to think about. Let's do some practice. 90 minus, let's see, minus 1.83. I can't write very well with this pen. And what you're going to get is 88.17. And you're going to underline, because it's addition and subtraction, the place of significance. For this one here, it is the hundredths place. For this one here, it's a tens place, because this 0 is insignificant. Now, if it had a decimal, it would be significant, but it's insignificant coming after non-zeros. So your answer needs to be round to the tens place, so you round this. And the answer is actually 90 again. Some people do not like that. How does 90 minus something become 90? Well, think about it this way, and maybe this will help you. Let's say you are Jeff Bezos. Okay, you are the richest man on Earth at this point in time, and your net worth is somewhere around $200 billion. And all of a sudden, Jeff Bezos has to pay a parking ticket, which is $25. What is Jeff Bezos' net worth now? Still $200 billion. That $20 did not even impact his net worth, okay, in any significant way. It's not like we would say he has $199,999,999,975, which would be how traditional math would handle that. We would just make an estimate and say $200 billion still. $25 parking ticket, not that big of a deal to Jeff Bezos. Might be a big deal to me, to you, but not to him. Let's see here. This has 1, 2, 3 significant figures. This has 1, 2, 3. And you multiply these two. And let me get out my handy-dandy phone. And 2.45 times 25.2 is 61.74. And the answer needs to be rounded to 3 significant figures, or 61.7. Now that 4 is insignificant. Alright, this one, you have to round to the hundredths place, because this is in the hundredths, this is in the thousandths. So you add those together, and let me see, 86.03 plus 5.371 is, oops, getting ahead of myself. Look at these quick maths. That would be 91.401. You have to round to the hundredths place, so it would be just 91.40. That's your answer. And then this last one, this has 3 significant figures. 1, 2, 3. This has 2. So your answer must have 2 significant figures. And I type it in my calculator, 56.5 divided by 13. And I get this crazy number of 4.3461538 something. Okay. And rounding to 2 significant figures, that would be 4.3. That's your final answer. So if you still don't get it, that's okay, because it is tough and we'll have plenty of practice to go around, especially when I'm there to hopefully explain it just a little bit better than I do online. The last thing that you need to know in this PowerPoint is scientific notation. Scientific notation has to do with really big numbers or really small numbers. For instance, you have this nearest galaxy is 240000000, a lot of zeros, kilometers away. That's really hard to write out on board, right? So what we do is we just say it's 2.4 times 10 to the 9th power kilometers away. You should have done this in algebra. And how it is easy for me to understand is I put a dot right after this 0, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, until I get one number after the first number. 2.4 times 10 to the 19. That means there are 19 things after that 2. And because the number is really big, the exponent here is going to be positive. If the number was really small, the exponent would be negative. That's how scientific notation works. And you can see the vast difference between 1 times 10 to the negative 3rd meters, which is about the size of man, and 1 times 10 to the positive 3rd, which is about the size of a small town. Really big difference. Incredible. Scientific notation works on the power of 10, and so there's going to be a lot of things that, well, I should say it like this. Just a simple change in exponent is going to make a big change. I mean, imagine the difference between 3 to the power of 2, which is 9, and 3 to the power of 3, which is 27. 3 to the power of 4 is 81. And that's on the power of 3s. This is on the power of 10s. Pretty incredible, the differences. Starting out easy, 605 becomes 6.05 times 10 to the 2. That's because we went to the left 2 times. And you write 2 in there, and the exponent's positive because this number's big. And this number, 1, 2, 3, 5 times 10 to the negative third power. It's negative because this number's small. 6 million becomes 1, 2, 3, 4, 5, 6. 6 times 10 to the 6. And that is because there are 6 numbers after that 6. And so you have this little cartoon over here. Listen, Tom, when I said you needed to round up those figures, well, I didn't mean literally round up lasso. So it says, are you ready for a little competition? But we can't have a competition because sadly we are apart. But I would like you to try to do those on your own as I do them on the board. And if the substitute would so kindly show my answers on the board after this is complete, I will have the answers for you up on the screen. So you can begin now working on these scientific notations, and I'll have the answers on the board. Hopefully your substitute paused this so you could see the answers to the following conversions. And if you did that right, wonderful. If you did not, I will help you when I get back. I feel like I've said that a lot, but I will. And that is the end of section 2.1, page 28. Numbers 1 through 3, application 1 through 3. And that will be your homework to do for tonight. You can get started on that homework in class. I would like you, however, before we depart, to take a look at Lab 2 on accuracy and precision. Now, I actually was going to show an Abeka video on this, but unfortunately the Abeka video service does not include this lab. So we're going to have to do it on the day that we get back on Wednesday. And we're going to do this together in class. Hopefully it is just one more wonderful chance for you to get a good grade on lab. And please be mindful of reading that lab for tonight. Homework due tomorrow, lab not due tomorrow, but I would like you to read it. And thank you for your careful attention. We will revisit these things when I return.